Let's start this unit speaking about the pipe body. Pipes used in the oil and gas operations are manufactured following the rules stated by organizations for standardization, such as API, American Petroleum Institute, or ISO, International Organization for Standardization. The most important international standards for pipe manufacturing are the API 5CT and the ISO 11960, titled as Petroleum and Natural Gas Industries, Steel Pipes for Use as Casing or Tubing for Wells. These specifications are reviewed periodically, and in time, some steel grades have been deleted, new ones have been incorporated, and just a few of them have changed their designation. These standards specify the technical delivery conditions for steel pipes, which are related to steel grade designations, casing and tubing grades, manufacturing process and heat treatment requirements, chemical composition, minimum requirements for mechanical properties, dimensions, masses and tolerances, minimum requirement for non-destructive examinations, minimum requirement for product quality and logistics activities, additional supplementary requirements, and product specification levels. Let's go through each one of these categories, starting with steel grade designations. Steel grades are designated by a prefix letter and a number. The prefix letter that could be H, K, L, P, among others, has no special meaning, and its main purpose is to make a phonetic difference to avoid misunderstandings. And the number identifies the minimum yield strength in KSI, that is, thousands of pounds per square inch. With this nomenclature, there is a unique identification for each steel grade. For instance, in the grade N80, the N is an arbitrary denomination, while 80 refers to the specified minimum yield strength, SMYS, which in this case is 80 KSI. Then we have casing and tubing grades. The different grades are classified in 4 main groups: 1, 2, 3, and 4. And within each group, different specified yield strengths are associated too. The main characteristics for each group are: Group 1 covers the low-strength pipes and has no corrosion resistance. Group 2, these pipes can be used in environments containing H2S, and a strict process control during the manufacturing is required, since the allowed yield strength range is reduced 50% compared to Group 1. Group 3, these are high-strength pipes with no corrosion resistance. And Group 4 are very high-strength pipes with no corrosion resistance. Regarding manufacturing process and heat treatment requirements, steel pipes can be manufactured by either seamless process or by an electric process welding steel plates into a rounded shape. Depending on the steel grade, some of them require non-special heat treatment, whereas for others it is mandatory to manufacture them following specific heat treatment, such as normalized, quenched, tempered. The next consideration is the chemical composition, which, though established by the standards, provides a very wide range of options for each element. For each particular grade, the minimum and the maximum limits of the main alloying elements are stated. as well as the maximum acceptable for residual elements, which are detrimental for the quality of the steel. Each pipe manufacturer defines its actual chemical compositions. In this sense, the pipes supplied by different manufacturers can be designated with the same grade, that is, with the same name, even though they may differ in the chemical composition and in the actual mechanical properties. Almost all the grades are carbon steel-based, except for the L80 that, though being also carbon-based, it contains 9 or 13% of chromium for some special purposes. Then we have the minimum requirements for mechanical properties. The API 5CT and ISO 11960 standards specify the yield strength range, the minimum tensile strength, the toughness, the hardness, and the corrosion resistance for each one of the steel grades. Additionally, to guarantee homogeneous heat treatment for high-strength materials, the hardness variation in the wall thickness is required to be within a defined range. Talking about dimensions, masses, and tolerances, for each OD, the mass, the internal diameter, the wall thickness, and the drift are specified for the different nominal lineal masses. Moreover, 3 length ranges are established for the different pipe applications. Minimum requirements for non-destructive examinations include hydrostatic test, dimensional control like diameter, wall thickness, drift, and length, as well as mass determination and straightness evaluation. Marking methods, color identification, internal and external coatings for protection during both transit and long-term storage, thread protectors, product certification, documents and packing are defined as minimum requirements for product quality and logistics activities. Additionally, supplementary requirements, or just SR, are specified in the annexes of the API 5CT ISO 11960. Not necessarily all the supplementary requirements described in the standards will apply to all the pipes users. Normally, users ask for those supplementary requirements according to the expected well service conditions. These supplementary requirements may demand a special chemical composition or additional non-destructive testing or other activities that will have a direct impact on the manufacturing complexity and, of course, on the cost. Just as an example, some supplementary requirements are SR1 and SR2, which refer to imperfection depths at the surface of the pipes according to the specified pipe wall thickness. The SR15 speaks about the specific information to be recorded for the material certification. The SR16 are the general requirements for impact testing, and so on with the rest of the SRs. And finally, we can talk about the product specification levels. Since oil and gas exploration and production became harder, more complicated, the latest revision of the API 5CT ISO 11960 introduced a new concept to classify the quality of the manufactured pipes. This is the product specification level, or just PSL. PSLs were created analyzing technical specifications from different oil companies, collecting the most common requirements and aggregating them into 2 groups, named PSL2 and PSL3, keeping the name of the PSL1 for those products related just to the API ISO standards. Based on this, the OCTG products available today can be specified either as standard PSL1, that is the least demanding, PSL2, or PSL3. Differences from PSL1 to PSL3 are related to the material performance, to the inspection levels, and also to the inspection frequencies.